Behaviors our classroom. Today we'll start alcohols, a new chapter. In this alcohols, this is the part 1, and in this we will be discussing about preparation and properties. I am B. Venkatrao from Government College Autonomous, Rajamahendravaram. Hydroxy compounds. Alcohols are also called as this hydroxy compounds. So which compounds are called hydroxy compounds means those compounds in which there is at least one OH group, like this. Okay. So alcohols and phenols can be regarded as monoalkyl and monoaryl substitution products of water. This is one way of studying hydroxy compounds. We know the formula of water HOH. So in this, if this H is replaced by an R group, that is alkyl group, then that molecule is called as alcohol. And similarly, if this H is replaced by an aryl group, AR, then that type of molecules are called as phenols. So this is the general outline for hydroxy compounds. Have a look over the syllabus. This is the prescribed syllabus for your study. In this syllabus, you have some important topics like pinacol, pinacolone rearrangement, similarly some named reactions, Raymer-Tiemann reaction, Goldschmidt reaction, Fries rearrangement, Claisen rearrangements, etc. They are very, very important for your regular theory exams as well as competitive exams. Okay, be thorough with these topics. As far as the beginning of this alcohols chapter is concerned, alcohols are organic compounds containing hydroxyl group. I already told you this one. ROH is the general formula of alcohols. Similarly, compounds with hydroxyl group bonded directly to an aromatic, that is benzene ring, are called as phenols. Some examples of alcohols. Methyl alcohol, formula is CH3OH. Ethyl alcohol, also called as ethanol, CH3, CH2OH. Propyl alcohol, CH3, CH2, CH2OH. Isopropyl alcohol, CH3, CHOH, CH3. Tertiary butyl alcohol, CH3 thrice, COH. Okay, benzyl alcohol, C6H5, CH2OH. Similarly, vinyl alcohol, OH group attached to vinyl group. Vinyl group is CH2 double bond CH dash. Now, vinyl alcohol is CH2 double bond CH single bond OH. Allyl alcohol, OH group attached to allyl group is called as allyl alcohol. CH2 double bond CH CH2OH. So this is allyl alcohol. These are some familiar examples belonging to the class alcohols. Regarding alcohols, they can be considered as versatile organic compounds. Very dynamic. Okay, why they are called as versatile organic compounds means they can be derived from many types of compounds. That means we can very conveniently and easily prepare alcohols from other types of organic compounds. Similarly, an alcohol can be very conveniently converted into several other types of organic compounds. That's why alcohols are considered as versatile organic compounds. You observe this chart. You see, Rx is alkyl halide. Alkyl halide can be converted into alcohol. Alcohol can be converted into alkyl halide. How? We already studied these things. Rx is alkyl halide. Just now I told you. When Rx is subjected to reaction with, say, dilute alkali like aqueous, KOH or NaOH, then it gives rise to alcohol. Similarly, this alcohol, when treated with PCl3 or PCl5, PBr3, PBr5, SOCl2, etc., it gets converted into alkyl halide. Okay, similarly, ester. Ester can be readily converted into an alcohol by hydrolysis process. Alcohols can be converted into ester by esterification process. Carboxylic acids. Carboxylic acids can be converted into alcohols. Alcohols can be converted into carboxylic acids. Alkenes. By hydration process, alkenes can be converted into alcohols. By dehydration process, alcohols can be converted into alkenes. Ketones. Okay, ketones can be converted into alcohol. Alcohol can be converted into ketone. Similarly, an aldehyde. Aldehyde group can be converted into this alcohol. Alcohol can be converted into aldehyde. Ether. Okay, very easily alcohols can be converted into ethers. Similarly, we can obtain alcohols from ethers. So this is only a small description of how versatile an organic molecule like alcohol is. So that's why these alcohols are very, very important in organic chemistry. Classification of alcohol based on number of hydroxyl groups. Very simple thing. If there is one OH group linked to sp3 carbon, then it is a monohydric alcohol. A simple thing. Dihydric alcohol, 2 OH groups. Trihydric alcohol, 3 OH groups. I have given the examples also. Glycerol or glycerin, this molecule. It is ethane diol. Okay, ethylene glycol, it is called as. If there are more than 3 OH groups, then they are called as polyhydric alcohols. So this is one way of classifying alcohols. Similarly, classification of alcohols into primary, secondary, and tertiary. This is also important. Okay, this is OH group, the functional group. Functional group linked to CH2 group, then it is a primary. OH group, functional group linked to CH group, a secondary. Okay, and OH group linked to C, it doesn't have any hydrogen, then it is a tertiary group. Or in other words, it is this carbon, OH containing carbon is linked to 3 other groups, then it is a tertiary alcohol. This is one way of classification of alcohols. Next, we will go to preparation of alcohols, very, very important area. One method which I am going to discuss with you is hydroboration oxidation. The process is, first we are carrying out hydroboration reaction, then it is subjected to oxidation. The oxidation is carried out with hydrogen peroxide in alkaline medium. How this reaction is carried out? You just observe this one. Diborane, B2H6 or BH3 twice. Diborane reacts with alkenes to give trialkyl boranes. That is the first step. Trialkyl boranes are formed as addition product. This is oxidized to alcohol by hydrogen peroxide in the presence of aqueous sodium hydroxide. Okay, hydrogen peroxide and sodium hydroxide are required. Take for example an alkene like propene, CH3, CH double bond CH2. It is reacted with BH3, that is half of diborane, in tetrahydrofuran. This is the solvent used for this process. Then what is the molecule obtained? Tripropyl borane, CH3, CH2, CH2 thrice B. Tripropyl borane is the product obtained. This acts as an intermediate addition product, of course. Now this tripropyl borane is subjected to oxidation process with hydrogen peroxide in this aqueous NaOH, that is aqueous alkali medium. Then the final product is N-propyl alcohol, CH3, CH2, CH2OH. Okay, this is a very, very important method of preparation of alcohols, hydroboration oxidation reaction. Another one from alkyl halides. This is a familiar reaction to you because already we completed alkyl halides. In alkyl halides, how this alkyl halide is converted into alcohol? Hydrolysis of alkyl halides with an aqueous solution of an alkali is a common and convenient method for the synthesis of alcohols. Already we studied about this reaction. RX is alkyl halide reacted with say NaOH or KOH in aqueous phase, then it results in the formation of alcohol ROH. For example, CH3, CH2Cl is ethyl chloride reacted with aqueous potassium hydroxide. The product obtained will be ethanol or ethyl alcohol, CH3, CH2OH. So this is another method, very convenient method which you are very much familiar with. So this reaction can be very easily reproduced in the examination. Another one is Bouveault-Blanc reduction. What is Bouveault-Blanc reduction? Bouveault-Blanc reduction is we take an ester and this ester is subjected to reduction reaction in presence of sodium and ethyl alcohol. An alkali metal is taken in presence of ethyl alcohol and reduction reaction is carried out. That result in the formation of alcohol. That reaction completely called as Bouveault-Blanc reduction. You study this reaction, it is a chemical reaction in which an ester is reduced to primary alcohols. Ester is reduced to primary alcohols using absolute alcohol and sodium metal. Sodium metal is this one and this one is absolute alcohol. Here 0 means it is a zero oxidation state, metallic state. For example, preparation of ethyl alcohol from ethyl acetate. Ethyl acetate formula is CH3, COO, C2H5, ethyl alcohol. Sorry, ethyl acetate. Now, when ethyl acetate is subjected to this Bouveault-Blanc reduction in presence of sodium and ethyl alcohol, then what happens is ethyl alcohol is the product obtained. Here the solvent is ethyl alcohol, the product is also ethyl alcohol. Okay, this is Bouveault-Blanc reduction, specifically mentioned in the syllabus, so practice this. Bouveault-Blanc reduction is also useful for preparation of alcohols from aldehydes and ketones, a similar type of reaction. Okay, another area, this is also very, very important, preparation of alcohols from Grignard reagent. You are familiar with Grignard reagent. Grignard reagent is alkyl magnesium halide, or MgX, or maybe alkyl group, X is halogen. Now, here what is important point is, Grignard reagent is reacted with carbonyl compounds. When Grignard reagent is reacted with carbonyl compounds, an intermediate product will be formed. And that intermediate product gets converted into alcohol by hydrolysis process. What is important regarding this process is, primary alcohol can be prepared, secondary alcohol can be prepared, and at the same time, a tertiary alcohol can also be prepared by using this method. How? Let us see. Grignard reagent plus formaldehyde followed by hydrolysis gives rise to a primary alcohol. Please remember this point. Grignard reagent reacts with formaldehyde, gives rise to an intermediate product. It is subjected to hydrolysis that result in the formation of 1-degree alcohol, that is primary alcohol. If Grignard reagent reacts with other aldehydes means other than formaldehyde, then the product obtained will be a secondary alcohol. The same reaction, Grignard reagent reacts with ketones. Now the term is that of ketones. Then which type of alcohol is obtained is a 3-degree alcohol is obtained, that is tertiary alcohol is obtained. So in this way, alcohols can be easily prepared from Grignard reagent by making use of carbonyl compounds, aldehydes and ketones. This is the detailed explanation for that. RMgCl, Grignard reagent, alkyl magnesium chloride, reacting with formaldehyde. So this is the mixture, these two mixture, then subjected to hydrolysis reaction, then it results in the formation of primary alcohol. RMgCl reacted with aldehyde, RCHO, okay, followed by hydrolysis gives rise to a secondary alcohol like this, R2CHOH. RMgCl reacted with a ketone, RC-O-R is ketone. A product is formed that is subjected to hydrolysis. Finally, a tertiary alcohol is formed. So this is the method of preparing alcohols, primary, secondary, and tertiary, by making use of Grignard reagent and carbonyl compounds. Coming to properties of alcohols. As far as alcohols are concerned, they have some specific properties. What are those specific properties? Means high boiling points, high solubility in water, like that. These specific properties are due to hydrogen bonding. So hydrogen bonding plays very, very important role for deciding the properties of alcohols. I'll explain how it is. The oxygen-hydrogen bond is an especially polar bond because oxygen is much more electronegative than hydrogen. There is a lot of electronegativity difference between hydrogen and oxygen. Therefore, what happens is the bond between oxygen and hydrogen is a polar covalent bond. The OH bond is therefore a polar bond, and any molecule which contains an OH bond like an alcohol is a polar molecule. Now, hydrogen bonding of alcohols. Alcohols hydrogen bond to water. Alcohols have the ability to form hydrogen bond with water. Why it is? Because means alcohols have OH group, it is polar in nature. Water is a polar molecule. Since both of them are polar, there is possibility of hydrogen bond. These blue lines. Okay, these blue lines correspond to hydrogen bond. And due to that hydrogen bond only, the properties are elevated, like solubility, boiling point. Similarly, alcohols also hydrogen bond with each other. Not only with water, they have the ability to form hydrogen bond among themselves. Okay. Now, boiling points of alcohols. Because alcohols hydrogen bond to each other, they have higher boiling points than alkanes of the same molecular weight. Okay, why higher boiling points? Why higher solubility in water? It is due to ability to form hydrogen bonds. Similarly, we can take up some chemical reactions also of alcohols. Alcohols react with active metals like sodium, potassium, aluminum, etc. And they result in the formation of compounds called as alkoxides. Okay, for example, ROH, alcohol, reacting with sodium metal gives rise to RONA, sodium alkoxide. Okay, for example, CH3CH2OH reacts with sodium metal gives rise to sodium ethoxide. Of course, hydrogen gas will be liberated in this particular reaction. Do remember that point. If it is tertiary butyl alcohol, okay, aluminium tertiary butoxide will be formed. This is the general formula. So if you write this reaction, that may be sufficient as far as chemical reactions of alcohols are concerned. Reactions due to OH of alcohols, OH group completely replaced. OH group of alcohols can be replaced by halogens when reacted with, you know this reaction very well. You studied this in alkyl halides. Phosphorus halides like PCl3, PCl5, PBr3, PBr5. Similarly, thionyl chloride, SOCl2, and hydrogen halides in presence of zinc chloride, ZnCl2 and HCl. It is a nucleophilic substitution reaction. You know very well about that. So this is the detailed explanation regarding reaction of OH of alcohols. That means OH group is replaced by halogen atom. This is esterification reaction. Formation of ester from alcohol and carboxylic acid is called as esterification reaction. So the reaction is esterification reaction, and it is a reaction of alcohol with carboxylic acid. Ester will be formed. Alcohols react with carboxylic acid in presence of acids like sulfuric acid to form ester. Observe this one, ROH reacting with RCOOH in presence of acidic medium. A dilute H2SO4 may be required. RCOOR, this is ester. COO group is ester group. RCOOR is ester. Of course, water is eliminated. For example, ethyl alcohol CH3CH2OH reacts with acetic acid CH3COOH in acidic medium. Light heat is required. Ethyl acetate will be formed. Ester CH3COOC2H5 is ethyl acetate. So this reaction is called as esterification reaction. You must be very careful while studying this type of reactions. Sometimes they may even ask you to write detailed mechanism also. If it is required, we will deal in next class. Next one is, there are certain tests to distinguish between primary, secondary and tertiary alcohols. These can be called as reactions also. Reactions of alcohols at the same time, methods to distinguish between. That means identify primary alcohol from secondary alcohol and secondary alcohol from tertiary alcohol, like that. We have several tests like Lucas reagent test is there, a test with potassium permanganate, Victor Mayer test will be there, steric ammonium nitrate test will be there. All these tests are useful for your practicals also. Okay, let us see one by one. Let us start like this. First one is Lucas reagent test. Okay, primary, secondary and tertiary alcohols can be distinguished by Lucas reagent test. Okay, what is Lucas reagent means? It is a mixture of concentrated HCl and anhydrous ZnCl2. Please do remember this point. Lucas reagent. It is a mixture of concentrated HCl and anhydrous ZnCl2. Now, when 1 degree, 2 degree, 3 degree alcohol is treated with this Lucas reagent, observe what happens. If turbidity appears immediately, that is within 2 or 3 seconds, then it is a tertiary alcohol. Turbidity. Okay, clear solution will get converted into some precipitate-like appearance, turbidity. If turbidity appears immediately, it is a tertiary alcohol. If turbidity appears after 5 minutes or 5 or 6 minutes, something like that, then it is a secondary alcohol. 1 degree alcohol does not react with Lucas reagent at room temperature. You have to provide some higher temperatures, etc. But as far as Lucas reagent test is concerned, this is the method of distinguishing between primary, secondary and tertiary alcohols. This test is used for the identification of primary, secondary and tertiary alcohols. Okay, in this test, alcohols react with Lucas reagent to form alkyl chloride. Alkyl chlorides will be formed which are insoluble in water. Alkyl chloride is insoluble in water. That's why they appear turbid or they appear a white color substance residue, etc. Second one is steric ammonium nitrate test. So this test is also very important for distinguishing between primary, secondary and tertiary alcohols. We know very well that steric ammonium nitrate is a mild oxidizing agent. Okay, not a very powerful oxidizing agent like KMnO4 or K2Cr2O7. It is a mild oxidizing agent. Since it is mild oxidizing agent, it oxidizes alcohols to certain extent only. For example, you observe this one. Primary alcohols are oxidized to aldehydes, which in turn gives silver mirror test with Tollens reagent. Ammonical silver nitrate is called as Tollens reagent. Okay. Which substances give positive test with Tollens reagent? They are aldehydes. Silver mirror test it is also called as. If it is a primary alcohol, then they are oxidized to aldehydes with ferric ammonium nitrate, which in turn gives silver mirror test with Tollens reagent. Secondary alcohols get converted into ketones. They are not converted into aldehydes, but they are converted into ketones, which forms an orange colored precipitate with 2,4-DNP. Do remember 2,4-DNP is 2,4-dinitrophenyl hydrazine. This 2,4-DNP is a test for identification of carbonyl compounds. Carbonyl compounds means both aldehydes as well as ketones. Aldehydes as well as ketones, both of them give orange colored precipitate with 2,4-DNP. But what is important is, if there is a positive test with 2,4-DNP and negative test with Tollens reagent, then it implies that it is a ketone. If both are positive tests, that means 2,4-DNP test is positive, Tollens reagent test is also positive, then that substance is an aldehyde. Okay, that's why here you study this one. Secondary alcohols get converted into ketones, okay, which forms an orange colored precipitate with 2,4-DNP, but does not reduce Tollens reagent. It forms orange colored precipitate with 2,4-DNP, but does not reduce Tollens reagent. Then what is the meaning? It is a ketone. So secondary alcohols can be identified like this. Then what about tertiary alcohols? Tertiary alcohols cannot be reacted by ferric ammonium nitrate. So in this way, by making use of the ferric ammonium nitrate, we can very comfortably distinguish between primary, secondary and tertiary alcohols. Similarly, another reaction, oxidation with potassium permanganate. Theoretical as well as practical significance is there for this particular explanation. Oxidation with potassium permanganate. Please remember, when alcohols are oxidized, they get converted into carbonyl compounds. Carbonyl compounds in turn get converted into carboxylic acids. Carboxylic acids in turn get converted into carbon dioxide and water. And that is a sequence of reactions. Now, how primary alcohols get affected due to this potassium permanganate solution? Primary alcohols are oxidized to aldehydes. First, they are oxidized to aldehydes and then to carboxylic acids. Here, what is important is both aldehyde as well as carboxylic acid have the same number of carbon atoms. There is no difference. So, in presence of acidified potassium permanganate, in which form we are taking this potassium permanganate? In acidic form, that is dissolved in, say, for example, sulfuric acid. For example, ethyl alcohol first gives acetaldehyde and then acetic acid. RCH2OH, a primary alcohol. RCHO, an aldehyde. RCOOH, a carboxylic acid. What is important is alcohol first gets converted into aldehyde having the same number of carbon atoms. Then it gets converted into a carboxylic acid again having same number of carbon atoms. There is no difference. So alcohol gets converted into aldehyde. Aldehyde gets converted into carboxylic acid. So this is the sequence as far as primary alcohols are concerned. What about secondary alcohol? A secondary alcohol on oxidation gives a ketone with the same number of carbon atoms as the alcohol. So in the first step, ketone is formed. Ketone has the same number of carbon atoms as that of alcohol. But in the next step, there is deviation. Ketones are not further easily oxidized. It is not possible to oxidize ketones easily, but drastic conditions are required. However, drastic oxidations give a mixture of carboxylic acids containing less number of carbon atoms than alcohol. So that point you have to remember. They will have less number of carbon atoms than alcohol. You observe this one, CH3, CHOH, CH2, CH3. It is a secondary alcohol. 1, 2, 3, 4 carbon atoms are there. Here, it is a ketone, 1, 2, 3, 4 carbon atoms. But this is a carboxylic acid. It has lesser number of carbon atoms like this. That is the test for secondary alcohol. A tertiary alcohol. Tertiary alcohol is usually resistant to oxidation action of neutral or alkaline mild oxidizing agents. That means drastic conditions are required. In the presence of acid oxidizing agents like this acidified potassium permanganate on vigorous oxidation under drastic conditions, it gives a mixture of ketone and acid containing less number of carbon atoms. This is The tertiary alcohol, tertiary butyl alcohol, 2-methyl-2-propanol is the UPAC name. When it is subjected to oxidation, this is oxygen, gives rise to a ketone. Here it is acetone, having one carbon atom less. 1, 2, 3. Here how many carbons? 1, 2, 3, 4. One carbon atom less. This is further subjected to oxidation under drastic conditions, gives rise to carboxylic acid. Here the acid formed is acetic acid. How many carbon atoms are there? Carbon atoms are only 2 in number. So in the first step, one carbon less, and in the second step also another carbon less. So ketone is formed, and further oxidation gives carboxylic acid. Both of them will have lesser number of carbon atoms. Okay, in this way, today we were able to discuss a most important topic, alcohols, preparations, and